Alright, so what we're going to do here is look at arithmetic sequences. Now, an arithmetic sequence is a sequence of numbers that has a common difference between each term. So for a sequence such as u1, u2, u3, all the way up to un, the nth term, for an arithmetic sequence, u2 minus u1 will equal u3 minus u2 will equal u4 minus u3. For a formula, that allows us to calculate the nth term, any nth term, whether that's u100 or u2000 or un, it is a plus bracket n minus 1d, where a is always just u1, or the first term in the sequence, and d is the common difference. That formula is not given in the formula sheet. However, the sum formula is. The sum formula allows us to calculate the sum up to that number. So for example, the fifth term, S5, it would allow us to calculate what the first term plus the second term plus the third term plus the fourth term plus the fifth term is. And that formula is given in the formula sheet, but it is Sn equals a half n bracket 2a plus n minus 1d, close brackets. So if we look at example 1, firstly I'm just saying find an expression for un. Using our formula, we can see straight away that the first term is 6 and that the common difference is 5. So you can see it simplifies down really quickly to 5n plus 1. Now calculate u10, that's just subbing in. Now we need to get an expression, that tells us that the 10th term is 51. Now we need to get an expression for S of n, the sum formula. So there, straight away, I've simplified it down to a quadratic, which is 7n over 2 plus 5n squared over 2. Now all we need to do to calculate S20 is sub in again. So yeah, really straightforward way of using these formulas. Example 2 gets a bit more complicated. For the sequence 1, 7, 13, 19, what I want to know is when the sum first exceeds 100. So I'll write that out. So we want to know for what value of n do we first get above 100. So let's firstly get an expression for the formula. So I've managed to get a formula that is negative 2n plus 3n squared, but I need to find out the value for n for which S of n first exceeds 100. So that is just a quadratic. Now, I'm not going to do it here because it's not a factorizable quadratic, so you then have to use your quadratic formula. However, I'll jump straight to the answers, and we get negative, well, look at the answers off screen, negative 5.4 and n equal to 6.1. Now we need to think about for what values does n actually give a value greater than 100. It must be the first value above 6.1, which is a whole number. So for the sequence, because n needs to be a whole number, calculate when the sum first exceeds 100, it is when n equals 7. (6.1) is exactly when the sequence becomes 100, but we need the first whole number because otherwise it's not a full proper answer. 6 would not give the answer, and then you would have a negative term in theory, but that doesn't work in this sequence because the sequence does not go negative. So the answer is 7. Now, we've got example 3. S5, or the sum of the fifth term, is 85 for an arithmetic sequence. S10 equals 295. Calculate the sum to the 20th term. Now, I've not been told what the sequence is, I've not been told what the first term is, I've not been told anything other than what two of the sums are, but that's fine because we can deal with that. So what I've ended up just creating, using what I know, is two simultaneous equations in A and D. Now all we need to do is calculate them. So I've now worked out what A and D are for the sequence, even though I don't know any of the terms. The common difference is 5, the first term is 7. And now what I could do is then work out all of the individual terms. What's the point when I can just sub in those values for S20? comes out as 10 negative. So you can see, questions can be straightforward, just calculating sequences, but then it can get a bit more complicated and having to do a bit of problem solving. But that is an arithmetic sequence.